Good afternoon, everyone. Muito boa tarde. Peço imensas desculpas pelo atraso. Vamos dar a professora Cristiana Bolchini, é professora do Departamento de Eletrónica, Informação e Bioengenharia no Politécnico de Milano e tem interesse em áreas como metodologias para desenho e análise de sistemas embebedidos. Está interessada em trabalhar em técnicas de uso eficiente de energia. Então, a professora Bolchini vai fazer a sua apresentação com pelo menos 1 hora de tempo e depois nós podemos fazer as nossas questões. Cristina, you have 1 hour to make your presentation, please.
Understood. Thank you very much for your kind introduction. Let me share the presentation. Let's see if it is in the presentation mode.
Yes, now it is.
Okay, perfect. So thank you very much for your time and attention. And today I would like to talk about smart buildings and what ICT can do for energy efficiency and user awareness. Just an outline of the presentation. I would like to introduce some context to give you an idea of why I'm talking about these topics today, some motivation and aims behind the work that we carried out. And in particular, we will focus on two aspects, two objectives that have been addressed during the work of these years, which is energy efficiency and user awareness, as the title of the presentation said. In particular, my interest and my competencies focus on data collection, which means all the information that it is gathered in order to be able to carry out these tasks. Some conclusions will give some, let's say, lesson learned from these experiences. As I was mentioning, I would like to give you just a few hints on the context, the background behind these studies and proposals that we carried out. I have an a degree in electronic engineering and a PhD in automation and computer science and engineering. My main area of interest is actually not necessarily the one I will be talking about today, and it is mainly focused on methodologies for the design and analysis of computing systems or embedded systems based on the application environment, but with a specific focus, so a specific interest on dependability aspects, which are the elements that allow us to design things so that we know in advance that these things might break down sooner or later because nothing is everlasting. So the idea is to design this kind of systems and components so that as soon as problems arise, they are able to, first of all, let the rest of the system know about it, and hopefully also put in place solutions that will enable the somehow automatic, but mainly pre-designed management of these anomalies. My other interest is on context awareness in data design and management, which is actually what led us, me and the other people working on these topics, into the exploration of issues related to the use of ICT for the development and the design or put in place of solutions for smart buildings and districts. So the main idea was not related strictly to a single building, but also to a set of buildings within the same district to try to improve energy efficiency. My interest started from the point of view of designing the data that's necessary in order to enable these decisions and strategy towards energy efficiency, the data design, but also the management. And context is a key aspect in order to be able to make everything flexible and adaptable to different contexts. One of the main characteristics of all my work in whatever area of interest is usually characterized by the idea of possibly starting from case studies, but to generalize whatever we propose as a solution so that it is possible to apply the strategies, the methodologies to different contexts. With respect to this topic of interest, and so the use of ICT solutions in this context, two are the projects that have been completed in the past years, where my competence is actually focused on, as I said, data design and management. And a few other experiences have been carried out, not necessarily under the umbrella of a project. And we are actually involved now in the proposal of a new project, still working on enabling smartness in buildings or in residences, based on the collection of information and the management of this information in a smart way. So this is to try to contextualize the aspects that I will more in detail explore during this presentation, considering the things that I have been working on. As I will mention in my last slide, whatever ideas, concepts, results I am presenting today are actually the result of a large team of people, possibly different teams for the different projects, who have been working on different aspects, not necessarily the one I will mention, but being the two projects I'm mentioning through the presentation with examples and so on, I would like to acknowledge all their contribution, among which there is also the contribution by Luciano Baresi, Professor Baresi, in order to carry out the many activities that are behind the ideas I will show. So in the last slide, not because it is not the relevant part, you will see also the other contribution.
Sorry, the slide is not in slideshow mode. I don't know.
Is it not? What are you seeing?
I'm seeing, yeah, now it's okay.
Okay, perfect. Sorry, I thought it was. Okay, thank you for letting me know. Let me continue with the motivations and the aims behind the work that is being carried out during these projects, but which is general, quite general to other strategies, other issues and problems that are addressed when we talk about energy efficiency and user awareness. If we look at energy usage and the percentage of or the quantity of energy and the application fields where it is devoted, we see that there is a growing interest in trying to make sure that the energy consumption within the buildings, which accounts for most of the energy spent for making everything work out, has, let's say that the energy spent is wisely and efficiently spent. Here, if we look at where the energy spent in the left chart, we see the destination with residential buildings that actually collect most of the usage of energy, to commercial one, and we have also industrial, and a total of what it is, the buildings as a total. Transportation surely has another interesting contribution to energy usage, but from that point of view, we have all different, let's say, problems and opportunities to try to reduce energy usage. If we go and take a look at the right-hand side chart, we see within a building where the energy is spent. For sure, as we might expect, a lot of the energy and the effort is spent on the lighting of the spaces. The space heating and cooling is actually related to where the building is placed within a country and the characteristics of the environmental conditions in that country within the seasons and so on, but still it amounts to a 27% altogether. And we have ventilation, the water heating, electronics, refrigeration, computers based, or let's say electronics based on the destination of the usage of the building themselves, and cooking when we are thinking about residentials and other kind of usage that are actually not differentiated. Anyway, the most, let's say, of the energy is spent to guarantee the quality of the inside environment for those who live in these spaces, which means heating and cooling and the lighting. So if we think about this usage of energy, it comes to a straightforward consideration and conclusion that by improving the energy usage devoted to this kind of activities, it is possible to reduce the overall footprint of the buildings. If we go one step further and we see where the, let's say, effort and attention of the European Union is with respect to efficiency in buildings, and where they are trying to focus with respect to the idea of zero energy buildings, we see that there are several aspects that play around the central idea of the smart building. We have the smart district and the smart grid, which are places within which the building lives. The smart grid is the provider from a certain point of view of the energy, and the strategies, the techniques that we can try to adopt and to exploit in order to work towards this kind of goal of energy efficiency relate to four main areas. From a certain point, we have the policies, the regulations that the countries can put into place in order to try to reduce the use of energy. For instance, in Italy at present, there are some rules for winter, for the winter times or the summer times related to how much the maximum degrees that should be kept within the residential spaces or the public spaces during the winter. So we shouldn't have more than 18 degrees inside. And during the summertime, in order to reduce the usage of energy, it is not allowed to have air conditioning or other solutions to lower the temperature below the 25 or 26 degrees. So from one point, for instance, we have for sure policies and regulations that can try to put a cap on the energy usage. Retrofitting is another relevant aspect, which means that we are investing into the building themselves, into their structures, in order to reduce whatever gets lost in terms of heating or refrigerating when we are conditioning our spaces. Technology and awareness are the two other key elements that help us in trying to be let's say, more sustainable and efficient. For sure, we need technology on which we can rely in order to collect information on the status of the building and derive and define new strategies to reduce the usage and the costs. Awareness is the other aspect. The user itself, himself or herself, is the final end user of the energy. So it is fundamental to be aware of how the energy is spent and it is used to make sure that the user has some context and it's driven towards, let's say, more sustainable behaviors in order to make sure that the energy is well spent. So these are the four main directions towards which it is possible to contribute when we want to think about the smart building perspective and the usage of energy in an efficient way. I'm afraid I'm...
Grazie per questo e grazie per tutto il lavoro fatto insieme in questo periodo.
Ontem, três dos partidos que sustentavam o governo de unidade nacional não participaram na votação da moção de confiança. Mário Draghi conseguiu ainda assim 95 votos a favor e 38
I don't know about you, but I'm hearing in the background someone else.
Can you please mute who is not?
Peço para... Pois.
Thank you very much. Thank you very much.
Much better. Thank you.
Thanks. So if we look at this, I put the two references to the two projects that have been investigating and working on these issues. And if we look at the technologies, so let's say what the ICT can do in order to try to get to the objectives of energy efficiency, here there is this puzzle of things that are actually enabling or can be used towards those goals. There are also other things that we can add. For our projects, these are the things that we took into account. The two projects are named Scuola, which in Italian is school. So it's Smart Campus as Urban Open Labs, a project that work on finding the university hub, but also the residential spaces as open laboratory to experiment new solutions towards the energy efficiency. And on the other side, we had instead the EEB project, where the focus was, on the other hand, on zero energy buildings in smart urban districts. So there was a part of overlapping interest and needs, and at the same time, the existence of two different projects having similar requirements allowed us to work in such a way that whatever solution we were devising for one context was going to be general enough to be applied also to a different context in order to make it more reliable and resilient too, and flexible, so that hopefully it can be also ported to different contexts and used as well. The elements here that are listed are the one with respect to the strategies and the technologies that have been really addressed, which go from the thermal comfort assessment. So the idea of being able to know whether the inhabitants, the occupants of the spaces are actually happy with the comfort that's being provided with the energy that's used in a certain way. The energy and user comfort optimization. So the idea of being able to optimize these kind of elements, the performance of the model. So the idea of how the building actually performs with respect to the dispersion of the indoor conditions with respect to the outside situation. So the idea of being able, through the monitoring of the behavior, to extract how the building facade works with respect to the environmental conditions. The occupants' experience improvement, as I was mentioning, certifications and standards, which are the elements that in the end drive some choices when we design or plan for a building to work in a certain way. the real-time monitoring and controlling, which is something that we have been doing forever in our buildings when we think about the control of the conditions of the rooms, the temperatures, the humidity, and so on. And what we can put into place here are algorithms that, based on the collected information on the objectives, can do this by themselves in real time. As you may expect, artificial intelligence and all the algorithms and let's not say automatic, but for sure trained models can do is something that's going to work in this place very well in the future. We try not to forget the system interoperability and integration aspects, because most of the time, if we don't think about a residential space where the introduction of heterogeneous systems and components might be not so, let's say, relevant. If we think about an entire building or different buildings in the same district, for sure we are thinking about different electronic components, different systems to be that are already in place. So it is fundamental to keep in mind, also in the design and the strategies that are put into place, the fact that heterogeneity has to be handled and planned in advance. Also, if you think about any kind of building, the idea is that you might replace or any kind of system to be more general. Parts that break are going to be replaced. So in the end, it is important to think that we will not have the same identical situation of all components of the same brands in the same place. The last two items here listed are the energy usage assessment. So the fact that we want to be aware of how the energy is used, as well as the thermal comfort of the user. And last but not least, the decision support system. So something that is there to take decisions on how to operate the building in order to guarantee a reasonable comfort for the inhabitants and the sustainable usage of the energy. If we look at the overall picture and how we can think about the overall system, we have the fact that we collect energy information and the operational state of the building. We have the information also from the occupant, the users of these spaces, to make sure that we know how they feel about how we control the rooms and everything. And there is the facility manager, who is the person who usually takes the decision on how to manage and handle the environmental conditions and the energy usage within the building. The data is collected and made available through a platform where we have all the information on the building portfolio, which means the buildings that are all managed and are part of the same set. We have the weather forecasts to try to predict the energy request or the occupants' request with respect to how the buildings and the spaces will be all together managed. And the utility, which is again the manager that offers in this way the information about the energy provider and so on. So given this great picture, the idea is that we talk about smart building or the smart management of energy and so on when we imply somehow the presence of the technology that's put there, so that we are able to make the manual handling and decision making of things that become more and more complex still efficient and useful and convenient and profitable. For sure, if we think about our own house where we live, it has some kind of complexity to try to optimize our usage of energy towards our well-being. At the same time, when we think about a building with more spaces, more apartments, or the university campus, as we took as an example, there are so many different requirements, so many different conditions and specific goals within the buildings that having something like a strategy and a manager that is able to handle all the different requirements and goals is something really desirable. The promise is to program efficiency, so to be able to handle all these complex elements better than what a human being could do. The basis, the fundamental elements on which this can be done is the data collected from the system, which would be in this case both the buildings and the users themselves, because that's at the basis of any strategy, no matter whether it is human-based or machine-based. That's why we get here and to the focus of the, let's say, presentation, but also the contribution to this kind of projects. First of all, the idea is that we know we need to collect data, but what we want to do is to find an appropriate data collection campaign based on the outcomes or the goals that we are pursuing. If we think about it, data collection and all the AI looks at a situation where apparently we get a lot of data, we process it, and we simply get the answers out if the algorithms are working well. However, the data has to be designed and thought about in advance to be sure that we collect all the data we need, and at the same time, no more data that's strictly needed. One of the elements or of the aspects that somehow are crucial, not only today, but especially in the future, is the fact that also data collection is something pretty expensive. We need to collect data. This consumes energy for getting the data, storing the data, and make sure that we keep the data for as long as we need. So data collection should be planned in a sustainable way, as well as the goals that our methodologies aim at reaching through a nice exploitation of such data. If we can enumerate the aims of the contribution I'm presenting, the first one is to adopt... Yes?
Yeah, cum vai?
Maybe it was not a question. The aims are to adopt a methodological approach to support, to be able to design solutions for energy efficient buildings. So the point is, and the stress is on the methodological approach. The second element is to improve the occupants' comfort, which means that within the boundaries of the energy we want to use, the attention is on their comfort. And as a third aim, there is always the idea to lead the users towards a higher sustainability. So to make sure that they adopt the best behaviors in order to save energy when it is possible, and to use the energy in a smart way when necessary. Let me stress on the methodological approach, because the next elements I'm going to present are exactly in this direction. If we think about the problem, we want to monitor, for instance, this room where I'm sitting and the other rooms in the buildings, to try to understand what are the environmental conditions inside, so that it is possible to decide whether to start the air conditioning or the heater during winter time, whether the light is enough, or I'm switching on the light even when it is not necessary. And when I'm trying to decide what data to collect, I should have a methodological approach, not just to put some sensors to get data that is then data that is maybe not reliable or redundant or missing, or we have too much data and we don't know what to do with it. And it costs, as I said already, effort, time, and energy again to store data that I might not use. If we look in the literature, so when we start planning for something, we can try to look for other existing solutions. And the idea we got when we tried to start in this direction of the decision of how to monitor the environment in order to gather the information needed to drive the energy efficient policies as well as the occupants' comfort strategies was that what this seemed was that every building or every case study had its own solution, which could be quite difficult to understand in terms of why these choices. And from the other point of view, it was going to be difficult to replicate a similar setup when another condition raises. So the idea is that if we understand why we put this number of sensors or how we use the ICT in one way rather than another one, we can try to replicate the similar solution to similar buildings, for instance, or houses, without having every time to redesign from scratch whatever are the policies that we are putting into place, especially from the data collection point of view. So what we worked on was a framework, a methodological framework and multidisciplinary, because we work closely with architects and engineers of the civil branch, mainly interested in designing buildings and building buildings with all the characteristics of the monitoring or very long experience in monitoring the buildings from this environmental point of view. So the idea was to try to have a framework that can help the designer, so the person who has to design the monitoring campaign or to put in place the overall system, to decide what to monitor, how to monitor the various elements, and how to use the data. The framework also would like to address and offer a systematic approach in choosing among the very many alternatives that are there. I will show them in a moment so that everything becomes hopefully clearer. And the final additional added value was to be able to use the framework also to classify and see how the other solutions that are available are actually organized. Because through the lenses of this framework, it is possible to pinpoint the solution of the other buildings or smart buildings to try to find the benefits and the limitation of other approaches to make let's say, more robust implementation for the implementation and the case study we are addressing. Let me show you the framework. The framework is actually an instrument which is something that is needed to state what we are interested in with respect to all the possible facets that we were able to think of. The framework is not necessarily exhaustive, which means that if we haven't thought about a specific direction of interest, it is simply possible to add this extra direction, this extra dimension that classifies the solution we are investigating, and that's the flexibility of the solution. These are all dimensions. When we plan the monitoring of the spaces, these are the elements that are usually taken into account. As I said, we can add new ones or remove some if these are not relevant for the case study we have in mind. Let me briefly go through them, starting though from the most relevant one, which is the goal. So the objective of our monitoring campaign. This is the first and most important point, because it drives all the other choices in the monitoring and exploiting process. So if we look at the at this, let me try to put the marker on where I'm moving, if I can find where to put it. Okay, if you look at the objective dimension, this is the goal of the work. Are we looking and doing this kind of monitoring campaign to do an analysis of the comfort of the users? Are we doing it because we have an energy audit so that we need to know how the energy is spent? Is the final goal the visualization, because maybe we have a panel where we want to show the information about this building? Do we do this to collect or identify some anomalies, maybe something that's not working in our system? So the monitoring is only planned and deployed to detect problems. Do we want to extract the model of the building because we are planning a renovation, so we need to know how the building is performing now, and we want to, on the other hand, change these characteristics to optimize the usage of the energy? Or again, are we interested in the dynamic control, so the energy management system design for our building? Or last but not least, are we taking some KPIs to try to understand the building performance? So based on what we want to do, all the other elements will be selected, thinking and keeping in mind the final goal. If we look at these dimensions, let me mention some of them. First of all, the kind of campaign, which is actually used to differentiate situations where we have either a single setup, because we put a single setup that's going to be there forever till we end our data collection. The data temporal usage, which actually identifies whether the collected data will be used in real time. For instance, if we are designing the dynamic control of the building, or if we are using it for data visualization. In that sense, we really do not need to have a real-time access to data, but we have some kind of delay. The sampling strategy: how do we collect the temperature in the rooms? How do we collect the temperature or the humidity in the rooms? That's another important aspect, because that specifies what kind of data sampling is going to be adopted. Do we want, for instance, to sample and get a reading every 15 minutes, every half an hour, or do we want to have a reading every time the temperature, for instance, changes? So that's kind of how to set up in the end the sensors. The analysis time granularity is another interesting point. If, for instance, we are showing data or having an energy audit, maybe the analysis of how we aggregate data will be based on a possible time window, which is weekly average temperature or the daily average temperature. So in this sense, if we know how often we aggregate and with respect to which time window we aggregate our information, we will know how to sample data. The aggregation operator, that's another interesting aspect in this direction. And the segmentation strategy is, again, is related to timing aspects. So here I'm not going to get deeply in everything, but the idea is that if we know what we will do with the data, we can try to systematically decide how to handle data, how to collect it, whether we are interested in a certain precision of the data, eventually redundancy if we need the data to be very reliable, and how to do and how to handle missing values, because sensors will go possibly offline at some times if they are battery powered. If there are some resets or something, we might have some missing elements. How should we fill these missing elements? So there are so many things that we can choose, and this framework actually should lead the designer of the collection campaign, of the monitoring campaign, into taking choices that make sense, are replicable in different scenarios, and actually optimize also the amount, quality, and the quality of the data that we are gathering. Let me show you the choices that we did with respect to this framework for the Scuola case study. So in this case, we were interested in the comfort analysis for the users. So one focus was the dark green shade that takes all the points in this kind of radar. So it's the comfort analysis. And then all the other choices are in common with the two different scenarios. So we have two different scenarios here. One is the dark green scenario that touches all the points that you can see, and the light green scenario where the difference is on the dynamic control. So the same setup for two different goals: the analysis of the comfort of the user and the dynamic control, which is the energy management system. So the controller of the conditions of the building spaces based on some optimization policy. Since we wanted to have something that was going to be a dynamic control, the data usage was in real time, also with respect to the comfort analysis. The sampling was time driven, which meant that every X minutes we were going to sample the temperature, the humidity, and all the environmental elements. A machine was going to use the data collected. That's because we have algorithms that actually aggregate and use the information. So that makes a difference with respect to a human person in front of a screen that has to take decisions, and so on and so forth. So this is the main setup. The EEB project had some, again, comfort analysis, but from the other point, the relevance was related to the performance of the buildings from the thermal point of view. So the goal is the model extraction. Since is the user, the human user who has to exploit the data we are collecting, here we have a difference in this sense. And the type of campaign is a single phase, because we are establishing the status of the building before a retrofitting action. We have all the other choices. Here we see, again, two different goals, the light brown and the dark brown. From a certain point of view, when we think about the comfort analysis, we work on a seasonal scale, while on the model extraction, since we are trying to design how the building behaves with respect to the thermal from the thermal point of view, it is a month analysis, because based on the different months, we have different external conditions. To give you an idea of how, after selecting all the elements, we exploited this kind of information, is with the design of the collected data. We put, sorry for the overwriting of the extra message, we collected information about the temperature, the inside temperature, humidity, and the weather condition inside and outside. We had the information about the windows being open and closed, because we were mapping also the behavior of the user, the light being on and off, the quality of the air, the conditioning, lighting, and loads elements to see how the energy was spent within the room, and other humidity, temperature, and the lighting information within the room. Also in the corridors of the building, we put further sensors to try to match the behavior towards the external envelope of the building with respect to the internal part. So all this information was planned with the previous framework, and this was put into place. Here are some pictures of actually how this has been implemented. These on the outside of the window are the heat flux that we installed in order to get the temperature and the irradiation in the outside of the building. And these are the sensors that have been deployed inside the building, in the corridor or in the rooms. The bottom right element here is instead the energy monitor that tracks where the energy is spent within the air conditioning, the lighting, or the energy for supporting the electronics inside the offices and the elements. This is the setup of the office. So you see at the ceiling level a sensor on the table with some kind of redundancy to make sure that we are not missing information. And here we have the energy monitor next to the control panel. As I said, one final thing of the framework is the possibility to classify and compare the other solutions that are available from other researchers to try to understand which one of the solutions already existing are suitable for our environment. Should we design our own, or should we use something that's already in place that has been already planned for something else? And somehow it also helped us to make a reasonable systematic comparison. How do we use this data? Let me briefly go into the energy efficiency part and into the energy awareness from the user point of view. From the energy usage, as I said, in the Scuola project, we were interested in designing an energy management system. So algorithms that have, based on the policies of the manager, decide how to use the energy. The information that was collected was, besides the one in the environment of the spaces of the building, was the meta information to try to anticipate the requests with respect to what was necessary in terms of heating or cooling. The information about the solar panel energy production, so the production of energy from the solar panels. We are using also electric cars, so there is a problem of the recharging of the electric cars, and the electricity market, because in this case the utility vendor was selling the price of the energy at different, let's say, values. And A2A is the provider for the demand response opportunities for the energy market. So this is all the information collected, and the optimizer actually controls how to charge and discharge the storage of the energy, how to heat and condition the spaces, so the control of the temperatures within the building, how to enable or prohibit the use of the recharging of the vehicles based on how the rest of the system is using and producing energies, as well as the availability of some smart plugs distributed over the campus to allow the user to charge their own devices in a sustainable manner based on the energy being available throughout the entire campus. The objective is always to minimize the overall cost, however, without affecting too much the inhabitants' comfort. Obviously, if we penalize the users as much as they want, we can always have a reduction in the cost and the use of energy. the idea is to try to match the best and the most sustainable requests with the availability of energy from the different sources. The ICT infrastructure is quite distributed, and it was based on two main items: the systematic and complete data collection from field. So here we have a data repository that collects on the information on the photovoltaic production, the thermal consumption, and so on, all the profiles of the elements part of the system, together with the weather forecasts. We have all the information from the sensors and the actuators within the buildings and the smart spaces, with the control, the access to the control in order to actuate the policies, actuate the elements according to the policies that have been put into place. Here we have the core of the let's say this of the decision model, which is the energy management system that interacts with the demand side management model, which is the ones that provide eventually the energy or the requests to reduce the user of energy, because, for instance, the rest of the district or the city has higher requests. It is a centralized optimization energy strategy, so which means that we have a single module, the energy management system, that takes the decisions for all. Here we have a screenshot of some policies. Usually we had a request for the vehicle charging moment at a certain time in the day, for instance, after lunch. The idea is that when we have a request in order to reduce our use of energy in that moment of the day, it is possible to reschedule the recharging in order to meet some opportunities to save energy and earn money for the demand response opportunity. From the controlling point of view, talking about the assessment of the situation and the energy audit, we have some charts that monitor, for instance, the outside conditions, the humidity and temperature. So in this case of the humidity in the outside, in this case is inside with a recollection of the weather outside, so whether it is raining or not, and the power usage that tells us with respect to the different usage possibilities within the rooms where it is spent. They are in Italian as much as luci means light, so the yellow are the lights that are usually turned on during the last part of the day. Clima is the conditioning of the rooms, so the fact that we spend there the energy, and the rest is for supporting the computers in the room. So this is how the energy is spent. The other kind of assessment, even with respect to how the spaces are perceived from the user point of view. So the information about the thermal comfort expressed by the user of the office, whether it is normal, it's too cold or too hot, the humidity that's perceived, and the air quality. Altogether, to try to have everything in the same picture, if we look from the data point of view, this is the data repository with all the information coming from the collection of the data, how they are organized, and how the EMS, so the energy management system, takes this information in to gather the information and put the strategies to control the spaces, as well as other information to extract data analytics, KPIs, and provide other information. So this is mainly the same information organized in a different way. Let me move forward to just a consideration. Based on what we want to monitor, and because of the goal that we have, the framework allows to see, for instance, that we were oversampling the information, the conditions of the room, since it was easier and much more efficient rather than having, for instance, at the beginning, a sampling carried out every 6 minutes, as some colleagues were suggesting. By working on a 20 minutes sampling, we get exactly the same information so that the same policies can be adopted without penalizing the overall conditions. Let me quickly move to the user awareness, not to be too long. From the user awareness point of view, the optimization should not put the user in a condition that she or he doesn't want to stay in these spaces. So it is important to try to get their feedback and at the same time to educate them towards a sustainable behavior. Because sometimes the different way we behave has an impact on the final energy usage. What we devised was an application to be held on the smart devices, to be able to say in what location you are, so what kind of spaces that are controlled by this, that are monitored, and you want to express your thermal comfort, whether you are feeling too hot, and so on, the humidity level and the air quality. This kind of information allows us to gather the information and decide what action to take into account to improve the situation. While in the single office, the user has also the possibility sometimes to control their own devices and situation in terms of thermal comfort. In the classroom, for instance, students do not have the opportunity to independently go and change the temperature or the humidity. So these choices are going to be taken by the energy management system based on the perceived comfort and on the adopted strategies. If we move and we see this same information from a slightly different point of view, what we get is that still have the back information. These are the same charts I was showing before.
Can you please? Christian, I think you are the owner, not the host now, so I think you can mute.
I couldn't do it earlier. Oh, no, I can do it now. Okay. Okay. I tried earlier and I couldn't. Thank you.
No, yeah, yes.
Thanks.
You are the host now, so you can.
Okay. Let me come possibly to the conclusions. So I'm almost there. If we look at the comfort, so the temperature that are kept into the various rooms, the analysis, besides what the user actually expresses, which is for sure very relevant, the other point of view is the same comfort analysis with respect to regulations. In particular, there are in-state regulations where there are comfort classes, where they tell you what is the level of comfort within that space, which means that the comfort class A means that you are in a space with a temperature that is plus or minus 1 Celsius degree with respect to 24.5 in summertime. So based on when you are and the measured temperature, it is possible to assign the class of comfort for the room you are occupying. In the winter time, this is the other scale. So if you collect all the information on the monitoring, another kind of assessment you can do is for that building, the average comfort class with respect to the outside temperature with the blue line and the inside temperature. So it puts into relation the outside condition with the inside condition, which tells us something about the envelope, the performance of the building, and the class that with respect to regulation would be assigned to that building. So the data collection can be actually exploited in so many ways in order to try to get and have different visions and different interpretations of the same data based on what we want to do. For instance, if you see for the class of comfort, there is a single value or different values per day, but what it is meant, it's per user, which means that, for instance, you do not need to sample your information too often, because the aggregation you will have is on a daily basis. So what you are interested possibly is maybe sampling the temperature just 3 or 4 times a day, also considering how big the room is, and so it's maybe impossible for the temperature to have very steep variations. So it is fundamental to be able to think about all the aspects so that it is possible to make a sampling campaign that makes sense with respect to the goals that the final user has with respect to this aspect. Let me move to the next and concluding slides, if I am able to. Okay. From the environmental conditions, just to give you the same example and perspective I gave for the energy management system, these are the data that are collected, and these are the charts that have been planned in order to provide the information. This is again a different view with respect this time to the awareness about the environment. So we also provide information to the user about the situation of the energy usage. For instance, if the lights are on and the door is closed because you went home, because nobody is inside the office, a trigger can go on to let you know that the behavior is not sustainable, as well as if the air conditioning is on and the window is, for instance, open. So it's a different visualization of information we collect in order to get this. I think that the bottom message I want to give while I show the contributors to several of the aspects that we've been discussing here is that it's quite not so difficult to decide to collect information, and there are so many choices that can enable some smartness within the building or the spaces or our own home or whatever. The key point is that since there are so many options and so many alternatives, it is fundamental to try to be focused on the main direction and dimensions driving our choices, so that it is possible from a certain point of view to decide what to monitor and how to monitor. All the data we monitor, unless we throw it away as soon as it is used, it's going to be maintained, stored for a further analysis later on, which means that we have additional costs that are also affecting the energy. So it is really important to tailor the ICT strategies, technologies, and elements that we want to plan based on the final goals that we need to achieve in order to be sustainable also in the design itself of the overall situation. I think I concluded everything with this. So if you have questions, I will be happy to answer them.
Thank you, Christina. I think that now the colleagues will ask, and there is already one comment on the chat box.
Yes, I'm reading it now.
Ok. Ok, so, colegas, podem apresentar questões.
Maybe you can start from the one in the chat.
Oh, okay. Sorry, I didn't understand the sentence in the other language, if it was I was still reading it. So the question is, considering the cost of implementation of the technology, did you consider in terms of return of investments, in terms of or time in the specific project you have worked on? The cost of technology is important, yes, and we took that into consideration. The idea is that it actually impacts the breadth of the monitoring campaign in terms of the amount of spaces you want to monitor and for how long you want to monitor. Once you, it also depends on the fact that you keep everything there because you have, for instance, a monitoring campaign to do some assessment. So at the end, you gather all the elements and use them, reuse them for a next project. Or if these elements are going to be set into place because they're going to stay there because you're doing actually the final smart building. So the cost of technology for sure has an impact, as well as the kind of technology. If you do some kind of monitoring for just a limited time space for assessment, you can easily use wireless modules as the one we had in place. If you are doing something that's going to be part of the smart building, wired sensor are actually possibly a better choice, because once you put them in a certain place, you are not going to move them. And the batteries that run out are really something that is not so easy to handle, and it takes time and so on. So yes, the cost of the technology and the time frame of the monitoring campaign are two important aspects.
Kovel, are you okay?
Yes, I mean, okay. Maybe for instance, can we apply for a, or do you advise us to apply for a single house? Because
yes.
what I think, yes.
Yes, yeah. In one of the two projects, the Scuola projects, actually we have three different, let's say, locations. One was a residential house, so a single house. One was a building in the campus, our building here, and another one was an office in if I do not recall erroneously, in an industrial place. So three different also typologies of spaces.
Thank you.
You're welcome.
Colleagues, anybody else wants to question something, comment on something?
Good afternoon.
Good afternoon.
Yes, I would like to know if the management system in this presentation, is it related to the ISO 5001 standards? Because I see a lot of energy audit, and I would like also to know if did you consider the efficiency of the appliances? As you see nowadays, the light with you are using, and even air conditioners, they have many changes now, that if you use the previous ones, even the refrigeration that they use, they can consume, they have more consumption than the new ones.
Yes, all this, if I start from your first question, I believe that the energy management system, which was not part of the work I was actually focused on, was not related to the standard, but it was focused on developing or putting in place the policies according to the profiles of the energy production and consumption. So it was a set of algorithms to decide how to set up the different temperatures in the different buildings. So I think it was a simplified version from the research point of view. As for the efficiency of the appliances, we didn't use it in this specific work, but there was also some work done in another side project on the gathering of the profiles of the appliances, of all the specific appliances in a residence, in order to understand how that would impact the cost of overall usage of energy based on a change in the appliances themselves. So yes, that's something you do for the assessment, but through the extraction of the profiles of the single appliances in order to be able to better characterize their impact on the overall usage and the possible improvements if you replace the appliances, considering that you also have to estimate the cost and so on of the new appliance.
Colega Branco, are you satisfied?
Yes, I'm satisfied. Thank you for the answer.
Thank you. Any other question? Any other question, colleagues? I don't think so.
Okay.
So, if there are no questions, I think that we can close. Thank you for the wonderful presentation.
Thank you to everybody.
Thank you. I hope there is someone who wants to ask something. No, no.
Well, thank you, everybody. So as usual, if you have some, let's say, additional questions or you want to know more, you can send a message to the project email, and then we can send it to Cristiana, or you can send a message to Cristiana directly. So I'm not sure if her email address was on one of the slides. If it is, I do apologize. But anyway, as usual, it's her name, Cristiana, surname Bolchini at Polini. But if you use the project email, we can then forward it to her. But anyway, the email address is cristiana.bolchini@polini.it, which is...
Yeah, I'm afraid it was not on the slides, sorry.
No, it's on the chat now.
Yeah.
Okay, thank you. And next week we will have the summer school in Maputo, and I hope to be there. Well, I should be, but you never know these days. Thank you. Bye-bye.
Bye-bye. Thank you.
Bye-bye.
Bye.